So one of the other limitations that AI has right now is its resource consumption, right? It is a very expensive thing to run intelligence in general, okay? For example, at a human scale, our brains take up, their little thing here, take up just 2% of our body weight, but they use 20% of our human calorie intake per day. Okay, so even though it's a small thing by the mass, what it requires to power and function is actually quite a lot. And the same thing applies to computing power. Now, this is a little bit of my area of expertise because I actually sell compute power and servers in a day job. Yeah, so compute power is expensive. So the ability to run all of these functions, all of these algorithms on servers that take up a lot of processing power because it has to process a lot of complex information through complex algorithms all at once is extremely complex stuff. Most of the computing that is utilized for this stuff is high quality, high grade computing power, and that shit is just not cheap. Graphical processing, high performance compute, all very expensive because you have to process way more ones and zeros than the standard computer. So how this will change over the next decade is something called Moore's Law. So Moore's Law it's not really a law, it's a theorem that's based on anecdotal evidence. But basically that stipulates that computing power will roughly double every 18 months to 2 years based on the amount of transistors you can add into an integrated circuit. So the ability to run electricity through these transistors to process ones and zeros doubles every 2 years. And that's why we've seen the exponential growth in what is capable in a computer since personal computing started and general computing started in the 50s. Okay, it's been absolutely exponential in that time. So as that increases in time, and the role of the semiconductor industry, which is a key industry now globally, we've seen it be a political issue in Taiwan. We've seen the US release the CHIP Act to bring semiconductoring and manufacturing back onto US shores because it's a key component of the tech industry and what enables most of the global businesses nowadays, is that computing power is essentially doubling every 2 years. The role of the semiconductor industry is to get as fast and as cheap as possible, to be as efficient as possible, to be able to deliver compute into the market at a profitable rate. So as compute gets cheaper, the ability to run these processes becomes cheaper. Therefore, there is more of a margin, a profit margin involved in running these processes, and therefore it becomes more widely accessible because it becomes commercially feasible for organizations to utilize and sell compute. So that's one side of the fence of the computing capabilities and the ability to process information is high, but it is gradually slowing down, gradually decreasing. On the flip side, just like we said before, our brains take up a lot of energy. We are approaching a zero-cost energy future thanks to renewable energy and nuclear if you're lazy. So the power that's required to run these computers is not cheap, particularly now if you're in the Ukraine, and the computing power to run these very complex algorithms and data is also not cheap. So even though Microsoft and OpenAI has 100 million active users on ChatGPT, they would absolutely be smashed on computing power and general electricity to run all of these complex processes at once, particularly if they're running them in somewhere like Microsoft Azure, which I'm sure they are, which is a cloud computing platform that I've sold much of in the past. That shit ain't cheap, okay? It's not like it's just a basic fucking hard drive and a really basic, PC that can run ChatGPT. This is run in huge server farms, probably locally geocached in different regions. So what does geocaching mean? That they would take a copy of the algorithms and they would have smaller versions in local areas so the information doesn't have to travel as far to minimize the latency to get to the end user. That was very technical, but enjoy. So with ChatGPT, this stuff is computed at a distance in the cloud and then just sent to us in a nice little interface So we don't really see the sausage factory that's behind it, which is, thousands upon thousands of server farms consuming millions of watts of electricity, giving you this information. Now, a cash-rich organization such as Microsoft can afford to do this because strategically it wants to invest in this high profitable new emerging technology and grab as much market share as possible, okay? Because this is an emerging technology, similar to what we had with Bitcoin and fucking Ethereum, there was this gold rush, right? This gold rush of organizations creating shit coins and all this other stuff to buy into the hype and create market share in this emerging technology, in this emerging market that had not been captured yet. Now, Microsoft pretty much has the monopoly on this AI technology in the consumer world because it has 100 million active users at the moment. So it's probably likely running ChatGPT 3 or OpenAI at close to a loss or at a loss at the moment to get front of mind, to get presence. This becomes a strategic marketing play to be the first organization to market and lead the category. Because in marketing terms, if you want to become a massive player in your market, you want to lead the category of the vertical of the product that you're in, a subsection of it, such as Coca-Cola is the category king of the soft drink industry, right? So OpenAI and Microsoft now have a significant opportunity to be the category king of AI because they're the first to market on a mass scale to implement this and sell this to the market in general. So to maintain its potential share of market and share of wallet, it will try and get into as many organizations, into many people as possible and get them accustomed to using the product and make it sticky via association and comfort of using and the ease of using the product because they're used to it. That's a common trope that's used in marketing and in sales, is to get a person as close to the product, experiencing it as possible, so they feel like it's already a part of them and they're more likely to buy it and use it. And the problem is with this sort of stuff, just like cloud computing itself, it's a very sticky product. So when we say it's a sticky product, what we mean is it's very hard to get out of and exit out of once it's integrated into your ecosystem. And Microsoft has been very good with that for a long time as a software company, and then as a cloud company, and eventually as an AI company, okay? So I'll give you a perfect example. I'm in the cloud computing industry, or just the compute industry itself. Cloud, over the last 3 to 5 years, has become an emerging technology, and in the B2B world is pretty prevalent as the next step in the evolution of cloud computing, or just the compute industry in general. People used to have servers on premise and they all want to go into the cloud. And they don't want to have tin in their backyard anymore, or in their offices or in the data centers. They want to put it in Microsoft's cloud and Amazon's cloud for a variety of reasons: efficiency, simplicity, etc., etc. And Microsoft and Amazon make it very easy to put the data in there. Sure, come, use our products. They're quite cheap. They're going to be cheaper in the long run because it's so much more efficient and it's much easier to use. Realistically, it's not. And we're seeing a lot of people come off the public cloud back onto on-premise, which is perfect for me because that's the shit that I sell, on-premise compute. How it's a challenge for customers to get out of that cloud when they realize it's not the dream that they thought of is they charge for the egress, the exit of that data. So it's easy to put it in, but it's very hard to take it out, right? It's like a Chinese finger trap for computing and as a resource. So you put the fingers in, yeah, nice and easy, but you try and tug it out, uh-oh, what's going on here? Similar to AI. This will be a similar problem with AI because AI is not just replacing infrastructure, it's replacing functions inside a business. That's one of the main immediate benefits of utilizing AI, is to replace low or non-value adding tasks inside a business and minimize the cost of that operation. So if you've got AI that can do the work of 5 people or 10 people in a business, and you integrate that AI solution into your business and you go, this is costing me too much, or I think there's a better product, sure, take it out, but how the fuck are you going to do that? Because how are you going to replace that function in your business with a new solution without minimizing the downtime in the migration of that data, any of the assumed knowledge and learnings from that knowledge, from that AI, is probably going to be kept by the organization that sells it, so you're not going to get your data back. That's another big problem down the line, is how will organizations that give their data into the learning machine take it back if they don't want it to be in there anymore? Another huge problem. And then how will you replace one AI function with the other and make sure it learns it effectively without minimizing the loss of profitability, the loss of productivity in your business? That's another big question that IT leaders and organizations are going to have to face in the future once they utilize AI to replace labor costs in their business, which they inevitably will. So once it gets in, it's going to be very hard to get out, so you've got to learn how to master it and make sure that it's doing the right things for you inside your business, inside your life.